Okay, so the beginning of this hopefully is a review for you guys. So take a look at this right here. So that's kind of the notes right there. So you guys should see the vertical axis is the y-axis. The horizontal axis is the x-axis. And then you gotta know the quadrant numbers. So this is quadrant 1, and then you go counterclockwise. So this is quadrant 2, this is quadrant 3, this is quadrant 4. So other than that, the only thing they don't really have on there is you got to know, well, what's the coordinates of this point right here? Right there.
Oh, 0.
0 what?
0.
Yeah, 0, 0, right? And then that is called your origin. So I'll write that on there for you. So this point is called the origin. All right, and then we're just going to practice plotting these points over here to the right, that A through E. So then you should know that if, well, first of all, these are ordered pairs, right? So that first one, A there, if I write the ordered pair, if I write -4, 4, well, you should know the first coordinate there is the x, right? And the second coordinate of that ordered pair is the y. So all those points are in the form x, y. That's why they call them ordered pairs. And then, let's get over here where we can see the grid here. Okay, so then you guys should know that the first coordinate is x, so that tells you if you go left or right. If it's negative, you go left. If it's positive, you go right. And then the second coordinate, that's your y coordinate, that tells you if you go up or down. If it's positive, you go up. If it's negative, you go down. So then let me label my axes on here real quick too. So this is the x-axis right here. And this is the y-axis. All right? So then where do I go for that first point? -4 tells you which way. Yeah, go ahead. Yeah. Do you go right or left?
Left.
Yeah, left 4 and up 4. So left 4, up 4. So that point is going to be right. So let's see. Like, I need new glasses. I can't even see my iPad anymore. So we got left 4, up 4. I think that's right there, right? So then label that point A. You're supposed to use a capital letter when you label it. All right, then B, point B. So -2 tells me to go where? -2 for X.
2 to the left.
2 to the left. And then -3 for Y?
3 down.
And 3 down. Yep, so we got to go 2 left, 3 down. So 2 left, 3 down, that would be right here. So that's point B. So it doesn't look like a B. All right, we'll go with that. And then C, so point C, it's got a 0 for the X coordinate, so what do you do?
You're only moving over that one.
Yeah, so if it's a 0 for X, you don't go left or right at all. So then you're just going to go, the -5 tells you to go which way? Down 5, good. And that's from the origin, okay? So from here, you're just going to go down 5 from there. So that's going to put you right here. So that's point C. Now the part I've been forgetting here is we're supposed to say what quadrant these points are in. I forgot to do that. So A is in which quadrant?
2.
That's 2. So you're just going to write up here by the point A, you're going to write Q2 like that. So point A is in quadrant 2. Point B is in which quadrant?
3.
Good. So that's quadrant 3. So you write it like that. And then point C is not in a quadrant. What's it on? Good. So for that one, you write y-axis. And then point D, we didn't do it yet. So that one's 3 for x is 3 up, 7 for y, or sorry, 3 for x is 3 right, and 7 for y is 7 up. So 3 right, 7 up. So 3 right and 7 up. So that's like right there. Yep. So that's point D. What quadrant is that in? Yep, good. So that's quadrant 1. And then the last point, we got 2 for x, so that's 2 right. And we got -1 for y, so that's 1 down. So 2 right, 1 down. That is going to be right here. That's point E. Yeah, what quadrant was that again?
4.
Yep, that's quadrant 4. So that IV, remember, that's Roman numerals. That means 4. All right. So that's a review of how to plot points. Now we got to talk about how do we graph functions. So we got 3 examples there. So we'll just go right to it. So let's take a look at number 1 here. All right, so for number 1, they give us this equation, okay? That's our function right here. It's y equals 2x plus 1. And it's a function because for each x that I put in, I'm going to get out 1 y value, all right? So if you put in 1x, you get out 1 y. That's a function. And then here's my list of inputs right here. All right, and then I'm going to see what output I get for y for each of those x's. So what we're going to do is we're going to make a little table. So draw a little table here like this. And then the x's that we got to put in are listed right here. So we're going to put in, for x, we're going to put -2, -1, 0, 1, and 2. So let me do this. Like that. I guess I should have extended those a little bit. All right. So here we go. So what you're going to do is you're going to take the -2 and you're going to plug it in right there for x. So that would look like y equals 2 times -2 plus 1. So 2 times -2 is -4. -4 plus 1 is what? -4 plus 1. -3. Good. So that's a -3. So that's the y value for that x value. Then we got to keep going. We got to do the same thing. So then we're going to take the -1. And we're going to substitute that in for, hold on. And we're going to substitute that in for x. So that's going to look like y equals 2 times -1 plus 1. So 2 times -1 is -2. -2 plus 1 is what? -1. So that goes here for this y value. Then we're going to plug 0 in. So now we're going to take 0 and plug it in for x right there. So that's going to give me y equals 2 times 0 plus 1. 2 times 0 is 0, so 0 plus 1 is 1. So that goes there. And then it looks like I don't have a lot of room to do the last 2, but I'll just do them together with you guys real quick. So then we're going to take the 1, and we're going to plug it in for x right there. So 2 times 1, 2 plus 1. That'd be 3. So this one would be 3. And then we're going to take the 2 here. Take that 2, plug it in for x right there. So 2 times 2, 4 plus 1. That's 5, right? Okay, and then we're going to plot the points. So these, what you have here is you have your ordered pairs over there in the chart, right? So for example, this first point right here, that one, that's the ordered pair, -2, comma, -3. So we're going to plot all 5 of those ordered pairs. So the first one is -2, comma, -3. So -2, that is 2 to the left, and then -3 is 3 down. So -2, -3 would be here. Second point there is -1, -1. So that's 1 left, 1 down. So that would go right here. And then the next one is 0, comma 1. So 0, I don't go left or right at all. And then 1 means I go up 1. So that would be right here. And then the fourth one is 1, comma 3. So that would be 1 right, 3 up. That would put me 1 right, 3 up right there. And then the last point, 2 right, 5 up. So 2 right, and then, so 2 to the right, and then up 1, 2, 3, 4, 5. So I'm actually up here. Now, what do you notice about all those points? Yeah.
Make a line.
Yeah, they make a line. All right, so you are supposed to do that. So we're going to draw a line, so we're going to connect the dots here. So let me move this down just a little bit. So we're going to connect the dots like, ooh, I missed. Hold on. That's better. Now, I chose these 5 x values, okay? I could put any x values in that I want. I could put -100 in there for x. I could put +50 in for x. So that means I'm going to draw some arrows on the end of this line because it does keep going, okay? I could take an x value of 50, or I could take an x value of -100. All right, so those arrows mean that line goes on forever. And also, the reason I connect the dots, for example, I could do like, let's add one more point on here. Well, I'll do it separately because it wasn't really given like that. I'll just do it right here. So let's say we want to do one more point. Let's do 1.5. So I could do a bunch of fractions, right? That's 1.5. So what do you get when you put 1.5 in? When you put 1.5 in for x right there. What's 2 times 1.5? That's 3, and then plus 1? 4? Okay, so that would be 1.5 comma 4. Well, that point should be on our line, right? So let's try it. So if we do here, let's circle this in, maybe we'll put this in purple here or something. So this point right here, that ordered pair, I would go 1.5 to the right, and then 4 up. So that would put me right there. So do you see that would fill in the whole line then? Like I could do the same idea. I mean, I could do this for the rest of my life, right? I could make this list of x values. I could make that as long as I want. So I could take a whole bunch of fractions and put them in for x. And then what that's going to do is that's going to fill in all the gaps between the points, you know what I mean? So if I put all the fractions between, what do I got here? This is 1 right here, right? And that's 2 right there. So if I put a whole bunch of fractions between 1 and 2 in for x, that's going to fill in this part of the line right here, this part. That's going to fill that in. So that's why you connect the dots. Okay, and then people always ask, well, like, why do you graph the line? Well, every single one of these points is a solution to the equation. Does that make sense? So every single one of these, like if I put in, I don't know, if I use, let me get a different color here. So let's say I use this color here. So if I put in this point right here, what was the point that we had? Let's do 1 comma 3. That's this point right here, right? Well, that means the x is 1 and the y is 3. Well, that's a solution to that original equation. The original equation was y equals 2x plus 1, right? So if I plug in 3 for y, that would say 3 equals, and then I'm going to plug in the 1 here. I'm going to plug in the 1 for the x right here. So 3 equals 2 times 1 plus 1. Is that true? Yeah, that's true. That says 3 equals 3. So every single point is a solution to this equation right here. All right, so that every single point is a solution to that equation. Well, how long can I make this list? Like what x values could I plug? How many x values are there? How many could I plug in?
There's an infinite amount.
Yeah, I could plug anything in for x. So there's infinitely many x values, so that means there's infinitely many solutions, right? So that's why, and I won't do this on the next two examples, I'm just trying to explain. People are always like, well, why do we graph these lines? The line is a picture of the solutions. We cannot list all the solutions. This list right here would be infinite, okay? We can't write down all the solutions. So instead we draw the picture, and then every single point on the line is a solution. So hopefully that makes sense. But let's do the next two, and then we're done. So the next two, so we got to do number 2 here. Number 2, I probably want to erase a little bit of this out of the way here. Let's erase this stuff out of the way. Okay. So number 2, I got to fit it on this grid over here to the right. And let's just see, I'm not going to write all these down again. We'll write a couple of them down. Okay, so again, for number 2, we're going to make a table again. So draw yourself a table here. And put x and y. And then we're going to still plug in the same x values right here. Same ones we had last time. So we're going to plug in, for x, we're going to plug in -2, -1, 0, 1, and 2. Like that. All right, so again, for the first one, we're going to take -2, and we're going to plug it in right there for x. So we're going to get y equals -2 to the second power minus 3. Well, what's -2 squared? 4. What's 4 minus 3?
1.
That's 1. All right, let's do at least one more like this. So then we're going to put -1 in for x. Right there. So that's going to look like y equals -1 squared minus 3. What's -1 squared? That's -1 times -1. That's 1. 1 minus 3? So that's -2. Now the rest of these, well, I'll just do them with you guys. I'm not going to write them all down, okay? So the next one we put in is 0. So we put 0 in here. What's 0 squared? What's 0 times 0? 0. 0 minus 3? So it'd be -3. So this one would be -3. Then we put in 1. So we're going to take 1 and put it in here for x. What's 1 squared? 1 times 1? 1 minus 3? That's -2 again. Then we're going to put in the last one. So we're going to put in 2. So put 2 in for x. What's 2 squared? 4 minus 3? That's 1. Okay, so now we're going to plot those points over there on that grid on the right. So the first point is negative 2 comma 1. So that is 2 left, 1 up. So that's right here. The next point is negative 1 comma negative 2. That's 1 left, 2 down. So that's here. The next point is 0 comma negative 3. That's just 3 down. That's here. The next point is 1 comma negative 2. That's 1 right, 2 down. That's right here. And the last one is 2 comma 1. That's 2 right, 1 up. That's right here. And again, we're going to connect these with like a smooth curve. Let's see if I can do this. So something like that. So what kind of shape would you say that is? Oh yeah, that's called a parabola. That's good. What's the shape though? Kind of looks like a U, right? All right, that one's done. Let's do the last one. So last one, same thing. We're going to make a table again. Now notice on this one, they picked different x values. Do you see that? The first two, they used negative 2, negative 1, 0, 1, 2. This time they're using for x's right here. They chose 0, 1, 2, 3, 4. Thank you. So 0, 1, 2, 3, 4. All right. So let's do, I don't know. Let's just do this one. So we're going to take 0. We're going to plug it in right here for x. So what's 0 take away 2?
Negative 2.
And then you got to take the absolute value of that.
So 2.
2. Maybe the next one I'll write down for you guys so you can see. So the next one, you're going to take 1 and you're going to put it in there for x. So that's going to look like y equals the absolute value of 1 minus 2. And that's it, right? So then what is 1 minus 2? What's that? Negative 1. So we're going to take the absolute value of negative 1. What's the absolute value of negative 1? That is positive 1, right? So this one's going to be a 1. And then the rest of these, we'll just do them. So then we're going to take 2, and we're going to put it in here for x. What's 2 minus 2? 0. Absolute value of 0? That is 0. And then we're going to put 3 in. So for 3, we take 3 and put it in there for x. 3 minus 2? That's 1. Absolute value of 1? Good, that's 1. And then we're going to put the 4 in for the x. So take the 4, put it in there for x. 4 minus 2? 2. Absolute value of 2. That's 2. Okay, so now we're going to plot this one. So we got 0 comma 2. That's going to be just 2 up, right here. Then we got 1 comma 1. That's 1 right, 1 up. That's right there. Then we got 2 comma 0. That's 2 right and 0 up or down. And then we got 3, 1. That's 3 right, 1 up. That's there. And then we got 4 comma 2. That's 4 right, 2 up. So that would be 4 right and 2 up would be right here. That's right there. And then we're going to connect these dots. And this thing's going to make what's that shape look like? What's that? Yeah, it looks like a V. All right. Well, those are functions. Each of those graphs we did is a function because for each one x value that you put in, you get out exactly one y value. Okay. And then we should make a little note here, which for when you do your work. So we'll put a little note over here to the right. Is if the problem has a x to the first in it and you graph it, it's going to look like a what? A line. That was the first example we did. But then if the problem has a x to the second power in it, which is like our second example what we did, then the graph will look like this, which we said was kind of like U-shaped. And then if the problem has a, or the function I should say, has an absolute value in it, maybe something like this. So if you get one something like that, if it has an absolute value in it, then it's going to look like that, and it'll be like V-shaped. Okay, and that's it. That wraps up, that was the last lesson in chapter 1.